This is Professor Satish Oli from Civil Engineering Department. Today we are going to see regarding the experiment on orifice meter, and this experiment is a part of fluid mechanics lab for the 4th semester as per as VTU curriculum itself. So orifice meter, it is a flow measuring device and which is used in pipe itself, and we need to find out a CD over here. We need to find out the aim of experiment is to find out a CD value, that's a coefficient of discharge over here, and this is an observation table in that. So you need to find out a discharge of water collected with respect to rise of height of water with 10 centimeters and the time taken to that, okay, to rise at 10 centimeter height. You need to find out a differential manometer reading with respect to left rim and right rim, that is being given as H1 and H2. We need to find the difference of that for each set of readings over here. The observation here is the area of the tank, that is 0.09 meters per square. The diameter of the orifice meter, that is D0 equals to 16.77 in terms of mm. The inlet diameter of the orifice meter, that is D0, that is 25 mm over here. What we are going to do here is we are going to find out the area of the inlet pipe, that is A1 equals to pi B1 square by 4 into 10 raised to 6 in terms of meters. Again the area of orifice meter, so that is A2 pi 2d square by 4 into 10 raised to 6. Then we are going to find out the H, okay, so that is HM by 1000 into 12.6 over here. Then we are going to find a Q actual over here. So Q actual equals to A1 into A2 divided by under root A1 square minus A2 square into the root 2GH. Then we are going to find CD. So CD is nothing but Q actual by Q theoretical itself. We are going to do over here. So in the next coming videos itself. So thank you very much. Hi everyone. Today we are going to see experiment on fluid mechanics lab, and which is a part of 4th semester as per the VTU syllabus. Today we are going to take up the experiment on orifice meter. So this is an orifice meter which has got a circular plate inside it. It has got hole inside, and that hole dimensions will be in such a way that it will be half of that diameter of that pipe which has been taken to measure. It's a flow measuring device itself, and it is being connected with respect to a differential manometer head. With respect to a differential manometer head, okay, you can see here this is an YouTube differential manometer. Okay, so we have got a centrifugal pump over here, so which is used to pump the water, and the water is being allowed to pass through this orifice meter. Then it is being collected where we tend to measure an actual discharge, okay, and then it is passed to that pump itself. So what's the aim of this experiment? So the aim of the experiment is to conduct or to find out a CD value, or you can say it's an verification of the CD itself. Okay. So what we are doing here is you are finding out a CD value, okay, or you are verifying, or you can say you are calibrating when orifice meter over here. So you can use the two words. Either you can use the word calibration, or you can use you are finding out a CD value over here. So CD value here lies between 0.6 to 0.65. Okay. So how to conduct this experiment? So first what you need to do is you need to start up the pump. Before you tend to start up the pump, what you do is you do the timing work. So put the reading over here. Okay. So with respect to these two lumps, one is the left, one is the right limb itself. So with respect to that, now this value here is around, so with respect to a differential manometer reading, now with respect to this one, so you can see here it is around 15.8 itself. So what I am going to do here is I am going to write with respect to that value, that is 15.8. Now with respect to right limb, so it is around 1.8. So I am going to write the value of that right limb over here. that is 1.8 over here. Now what I'm going to do here is, I'm going to take, with respect to time, with respect to imagining a height of 10 centimeter, how much the time it is taking to fill that water. So now what I'm going to do is I'm going to close this discharge wall over here. Okay, I'm going to put a clock around 24. So I'm going to start with respect to 24. I'm going to take the reading with respect to 34. So now with respect to 34, it is around, say it is around 8.88 seconds itself. So 8.88 seconds. So what I'm going to do here is I'm going to write that seconds like 8.88. So the height is around 10 centimeter itself. So that is around, say, 100 mm over here. Okay. So this is my first set of reading. So again, similarly for the second set of reading, what I'm going to do over here is I'm going to vary the flow. Over here. And with that variation in flow, what I'm going to do here is I'm going to note what the differential manometer reading with respect to left and the right limb over here. So now it is around, say, 11 centimeters with respect to left limb. Now with respect to right limb, it is around 6.5. So that I'm going to mention over here. And now with respect to same thing, what I'm going to do is in collection time, I'm going to take what are the readings, actual readings with respect to that collection time itself. So now here I'm going to take in 15 centimeter. My stopwatch is not working properly. I'm going to reset it. Okay. So now what I'm going to do here is I'm taking an 18 as an imaginary point. And now with respect to 10 centimeter height, it will be around 28. So now for that I'm going to take it. Okay. So it is around 16.34. So 16.34 seconds. And the height is around 100 mm. Okay. So for the third set of reading, again what I'm going to do is I'm going to vary the discharge. Again, when I vary the discharge, there will be difference in pressure. I'm going to take the left and the right limb reading itself. So here it is around 9.2. So I'm going to enter that around 9.2. And the right one is we have got around 8.5, so 8.4. So that I'm going to note down over here itself. Now, what I'm going to do? Now again, I need to measure how much is the actual discharge because it is needed to measure Q actual itself. So now I'm going to close that wall. Okay. So I'm going to take an imaginary height around 8 centimeters over here. So I'm going to wait till that 8 centimeter height is been reached. Now I'm going to start my stop clock for that 8 centimeter. So 8 plus 10 is around 18. So I'm going to wait till the time that reaches around 18 centimeters height. Okay, I'm going to measure that time itself. So now with respect to 18 centimeter height, my reading is around 35.07 seconds. Say around 400 mm of height. So this is the experiment for an orifice meter, how to take the reading. Okay. So this calibration is very much important when you put a new set of instrument and you want to measure what the flow rate. Okay. So in the next half, what I am going to do is we are going to share how the calculation work has to be done. So stay tuned for my next video, which will show you how to calculate or how to find out the CD value for an orifice meter. So thank you very much. Hi everyone. Today we are going to see the calculation regarding orifice meter itself. So in this, what we need to do is we need to find out the CD itself. So CD is nothing but it is Q actual by Q theoretical. Okay. So CD value should be in between 0.60 to 0.65. Okay. So Q actual equal to what? So Q actual here equal to, we have a formula that is A into B into H by T. So here is nothing but length into breadth into height. Okay. So it is already, A has been given as 30, B is been given as 30, and H is nothing but that's a rise of water of 10 centimeter height. So that we need to have it. So all are in centimeters itself here. All are in centimeters. So now here the value of X, so that is a difference in manometer reading of left and right limb. So that is H1 and H2. Here we have already taken from the experiment. So here it is 18, H is 10, and for this first of set of reading, T is equals to 8 point, so this is 8.75. In the first, what we are going to do is we are going to find out the value of A1. Okay, so we need to find for Q theoretical. So Q theoretical equals to A1 A2 under root 2GH by under root A1 square minus A2 square. So we need to find A1 and A2. Okay, first. So for that, what we are going to do is we are going to find out A1 equals to pi by 4 into 25 square. So that's the value is around 4.9 centimeter square. A2 equals to pi by 4 into 16.77 square. So we have gotten value around 2.209 centimeter square. Okay. So now this is the first part. Now again, what we need to do is we need to find head coming flow water through orifice. So H here equals to nothing but Sm by S minus of 1 into X. So here Sm is nothing but it's a specific gravity of mercury, that is 13.6. S is specific gravity of water, that is 1, minus of 1. Here X is nothing but it's a differential manometer reading, that is 18. So now H equals to 226.8 centimeters over here. Okay. So next, what you are going to do? You need to calculate now. Fourth one, I can going to say here, Q actual. So Q actual, we have got a formula A into B into H divided by T. Okay, so A into B into H divided by T over here. So again, A is 30, B is 30, that is length into breadth into height. So height is 10, because the 10 centimeter rise of water that we have taken, T is 8.75. So here the Q actual value will be around 1028.75 centimeter cube per second. So now what we are going to do here is we are going to find the value of Q theoretical. Okay, so Q theoretical equals to A1 A2 under root 2GH by under root A1 square minus A2 square. So that is 4.9 into 2.2 under root 2 into 9.81 into H, that value have been found out earlier itself, that is 226.8. So divided by the under root 4.9 square minus 2.2 square. Okay, so we got in value around here is, that is 1642.50 centimeter cube per second. So now what we are going to do is we are going to find CD. So CD equals to what? Q actual by Q theoretical. So that we are going to find it. So now we got in value of Q actual. So that is 1028.57. So divided by 1642.50. Okay. So we will be having a value around 0.626. So this is the value of CD. So same way what we are going to do, we need to do is for all the trials we need to find out the CD value. Okay. So in this way we need to do the calculations of orifice meter. So thank you very much. So as you can see over here is key, you have got an orifice diameter plate. So that is been represented here itself. There is a flow is taking place. You got a cross section area of an vena contract and you got a cross section area of an orifice over here itself. Okay, and this is connected to this is an differential manometer which is being connected just before and just after the orifice itself. So now you can see in observation they have given the orifice meter diameter d naught, that is 16.77, and also they have given inlet pipe diameter, okay, of orifice, so 25 mm itself. So in the observation they have already given in the manual also, means this part is given in the manual also. So you got in length A as 30 centimeters and breadth B as 30 centimeters. So when we have conducted the experiment and we have recorded this data itself. So for the first trial you can see over here is we have recorded with the left with respect to left and right limb, and difference of that X is being represented over itself. Okay, and this is the H which is being calculated. Okay, that calculation I will show you furtherly. And this is the depth of water ice collected of 10 centimeter height and the time taken for that. And they have calculated volumetric discharge and also theoretical discharge and coefficient of discharge for all three iterations. Sorry, all three trials. You can see here itself the H has been calculated. The area has been calculated over here itself. This was wrong. I have corrected this one. And they have calculated Q actual by using this formula itself. We have seen in the earlier video also, the earlier part also. They have calculated CD. So from the three trials they have found out the CD value, and they have got an average CD value of 0.6. So it shows that it has been calibrated over here. Okay, so this was regarding the data sheet. So thank you very much. Stay tuned for my next videos also.